So the first trigonometric ratio we're going to talk about is sine. So let's go ahead and circle angle A on our triangle. Everything we do from this point on is going to be in reference to angle A. So we're putting ourselves right on this spot, right on vertex A. So imagine yourself, you're sitting on angle A. Which is the side opposite angle A? So think about, I'm sitting here, which side is opposite? Side A. So the sine describes the ratio between the side opposite and the hypotenuse. So sine is side opposite over the hypotenuse. The hypotenuse stays the hypotenuse no matter what angle you're on, but we're going to look at it from A's point of view. So the hypotenuse is C. And let's go ahead and just put down OPP so that we can say, yeah, I know that's the opposite side. I'm going to use that information again. So when you encounter your triangle for the very first time, circle the angle you're talking about and then label the sides. Hypotenuse, opposite, and then B is what we call the adjacent. I'm just going to abbreviate that ADJ. What would that be if we were in English class? Adjective, right? So here it's going to be adjacent. It just means that they're neighbors. So if you look, A is neighbors with B. Why can't C be the adjacent? Because it's the hypotenuse. It's already got a classification. It can't be the adjacent. Okay, so once you label your triangle, then you can put together your ratios. So the sine of A is A over C. It's the opposite side over the adjacent side. The cosine, and say this with me, cosine, we'll just say it again, cosine. So the cosine of angle A, so once again, if we're doing trigonometry, we circle the angle we're talking about in our problem, and then we circle it on our picture, is the adjacent side, which we labeled B, over the hypotenuse, which is C for us. And then the tangent side, say this with me, tangent, you can call that tan. This is the tangent side of angle A is the opposite side, which is a little a, over the adjacent side, which is B. So all we're doing is creating a fraction. And the word in between the trigonometry sign is the word up. So sine of A, cosine of B. So the way we remember this, and remember we're going to have to memorize these trigonometry ratios, sine is opposite over hypotenuse. So we use so what? To help us remember sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So we use ca to remember cosine. And then tan, or tangent, is opposite over adjacent. I kind of like tangent because he's the rebel. The other two use hypotenuse. And we, and Tan's like, I'm not like those other two. I'm not going to use hypotenuse at all. I'm going to use the opposite and the adjacent side. So that's why tangent kind of is my favorite out of all of them. It's taken a few years for me to have a good relationship with them. I used to hate tangent, but now I love it. It's good. We're building. All right, so we are going to find the sine, cosine, and tangent of the angle identified, and then we're going to leave it as a fraction. So remember, identifying sine, cosine, and tan is just writing the ratio between the sides. So if I want to find the sine of angle S, we're going to circle angle S. Then we're going to label our triangle. This is, oh, you guys have a 5 here. That's what I learned yesterday. And it's one of our special ratios. So we're going to have this side is the opposite because it goes across from our angle. 13 is the hypotenuse because it is across from the 90 degrees, or it's the longest side. Either one is true. And 12 is the adjacent side. So I'm finding the sine of S. It is the opposite side, 5, over the hypotenuse, which is 13. That's all. That's all it is. Just putting things, just making a little fraction. Cosine of S is the adjacent side, which is 12, so cosine is right here. The adjacent side, 12, over the hypotenuse, which is 13. That leaves us with tan is opposite over adjacent. That's 5 over 12. It's the only action item in this problem. It feels like, because it's trigonometry, it's going to be super hard, but all we have to do is identify. Okay, so I want you to take your pencil and I want you to cross out where we labeled opposite and adjacent. Because we are going to now look at sine, cosine, and tangent in terms of angle R. So we're going to circle angle R, and I'm going to go ahead and cross out angle S because I don't want him to get in my head. So we're going to look at angle R. We're going to find the sine of angle R. We're going to find the cosine of angle R. And we're going to find the tangent of angle R. So we have angle R is right here at this top vertex. Opposite of angle R is 12. So we're going to label that our new opposite side. So you see how there's really two triangles that live inside this one triangle, depending upon which angle we are talking about. And then 13 stays the hypotenuse, that's why I didn't cross it out. And then 5 is the adjacent side. So for sine, it's the opposite over the hypotenuse. Opposite side is 12. Hypotenuse is 13. Cosine is the adjacent side over the hypotenuse. Adjacent side is 5. Hypotenuse is still 13. And then the tangent is the toa, is the opposite over adjacent. So that's 12 over 5. Okay, so we are going to find the trig ratios of these specific angles. So we're going to draw two triangles. We're going to draw a 45, 45, 90, and a 30, 60, 90. So 45, 45, 90 is an isosceles triangle. The side lengths are x, and the hypotenuse is x times the square root of 2. That's our special right triangle. And then for 30, 60, 90, that's a tall guy. 30 is the skinny one, 60 is kind of the fatter one. We have our short side. We have our hypotenuse is double the short side. And we have our medium side is times our short side times the square root of 3. So we're going to trig ratio a 45-degree angle. So sine of 45, cosine of 45, and then tangent of 45. I'm going to do kind of my ratio work underneath my triangle, so leave a space there. So I'm going to go ahead and circle 45 as our reference angle. It's the one we're looking at. And then we're going to label our sides. This is going to be our opposite side. This is our hypotenuse. And then this is our adjacent side. So sine is so, S-O-H. So that is, sine is opposite over hypotenuse. So that is x over x root 2. Is it freaking you out that we don't have numbers?
No.
You guys okay? Cosine is the adjacent. That's the It's the adjacent over hypotenuse. C-A-H. Cosine, adjacent, and hypotenuse. So the adjacent side is x, and the hypotenuse is x root 2. Are the sine and cosine the same? Yeah, they're going to be the same. So if I simplify it, I only have to simplify it for 1 and it's equal. All right, tangent is the TOA. So, ka, TOA. So that's O is the opposite, A is the adjacent. So tangent is opposite over adjacent. Let's go ahead and cut to the chase on tan. X divided by x, that is 1. So the tangent of 45 degrees is 1. Always, by the way. And then x over x root 2. We're going to go ahead and cancel out the x's, and we get 1 over the square root of 2. We are not allowed to have square root in the denominator. So we have to multiply the top and the bottom by square root 2. When we do that, we get 1 times the square root of 2, which is the square root of 2. And we get the square root of 4. I know what that is. That's just 2. So really the sine is equal to the cosine. And both of those are equal to root 2 over 2. So let's take and make sure we highlight those numbers. Root 2 over 2 and 1. Okay, we're almost done. We're going to get through this same process for 30, 60, 90. I'm going to erase the work over here so I can use that as my workspace for my 30, 60, 90. I just needed to move my hint down. He was in my way. Okay, so I want sine of 30, cosine 30, and tan of 30. So sine is so, O-H, S-O-H. So O is the opposite side. So let's go ahead and circle 30. Let's label the opposite side, label the hypotenuse, and label the adjacent side. So the sine is the opposite over hypotenuse. That is x over 2x. I'm going to go ahead and simplify that down. X divided by x leaves us with 1/2. Yay! Cosine is the so-called AH. So it's the adjacent over the hypotenuse. So that's x root 3 over 2x. Let's simplify that down. The x's cancel, and we get root 3 over 2. So cosine of 30 is the square root of 3 over 2. And last but not least, the tangent of 30 is TOA. So that's O is the opposite, A is the A, adjacent. So that's x over x root 3. So the x's cancel, and we get 1 over root 3. Unfortunately, we cannot keep it as 1 over root 3. So we're going to multiply the top and the bottom by the square root. So we get the tangent is square root of 3, because 1 times square root of 3 is square root of 3. And then this becomes square root of 9. Square root of 9 is 3. So the tangent of 30 degrees is square root of 3 over 3. So let's go ahead and circle those answers. 1/2 root 3 over 2 and root 3 over 3. Okay, so you guys, I'm just going to quickly show you example 3, because when you see how easy it is to do on your calculator, you'll be like, what? This is cake. So we're going to look, we want to solve for D in this scenario. So I'm going to uncircle D, because we circle our, always circle our reference angle. How, which side is the hypotenuse? 14 or D? D. So let's go ahead and label that. So what, how is 14 related to 28 degrees? Is it the opposite or the adjacent? Opposite. Which trig function uses opposite and hypotenuse? So is the OH. So it is sine that uses, remember we did sine of angle A is opposite over hypotenuse. So this is the little equation that we're going to use. So we are going to put in 28 degrees for angle A. We're going to put in 14 for the opposite and D for the hypotenuse. I don't want you to be afraid of sine of 28 degrees. Do not be afraid of the sine of 28 degrees, because all it is, some calculators you have to put the, so check this, on some scientific calculators you have to put the angle in first and then apply the sine, and some calculators you have to put sine first and then the angle. So make sure you know your calculator before you use it like on a test. So for this computer calculator, I had to put 28 in, and then I took the sine. Make sure you are in degrees. If you do radians, it's going to give you something wonky. So here, our ratio for the sine of 28 is 0.469, and I'm going to round this to 5. So I don't want you to be afraid of this number. All it is a decimal. So we're going to say, we're going to keep that in our pocket. So I just wanted to show you how to use it on a calculator. We're going to cross multiply. So we're going to put sine of 28 degrees over 1. And we're going to solve for D. So we get d times the sine of 28 degrees is equal to 14. And then I'm just going to divide by the sine of 28. And I get d equals whatever 14 divided by the sine of 28, or 29.8. Okay, we're going to do that one more time. We're going to solve for x here. So we're going to circle our reference angle. We want, we're using things in terms of 18. 42 is the hypotenuse, and 18 is the adjacent side. So adjacent and a hypotenuse is cosine. So let me pull that formula. Cosine of A equals adjacent over hypotenuse. And we're just going to fill in our numbers. Cosine 18 degrees equals x over 42. I put the cosine of 18 over 1, and I cross multiply. 1 times x is x, and I have whatever 42 times the cosine of 18. I'll just do that on my calculator. So you guys seeing why it's important to have your own scientific calculator, especially now that we're doing trig? So 42 times the cosine of 18 is equal to 39.9. Approximate. I should put the approximate. Okay, so this is part 1 of the notes. We're going to do part 2 the next time we